right, and good evening, ladies and gentlemen, and welcome to the first Recreational Astronomy night of 2025. Hope you all had a good holiday. My name's Tom Luton. I'm the new Master of Ceremonies here because Paul Markov, after many, many years, has retired. This evening, Andy Beaton will be talking about the sky this month. We had Frank Dempsey scheduled in to give a talk, but due to technical reasons, we've had to postpone that. And so I will be giving a short talk on the recent auroral activity that we've been having in the past year. And then we'll be wrapping the night off with announcements from our new president, Scott Masterton. Let's pass things on to Andy with the sky this month.
Okay, am I live here? Okay, great. Hi, my name's Andy Beaton. I'm talking to you from my luxurious basement office in downtown Toronto, and I'm here to talk about Sky this month for the upcoming month of January 2025. People who have heard my talks before will recognize the agenda, the big picture, key dates, the sun, meteors, aurora, the moon and planets, asteroids and comets. In memory of my old friend Blake, I'm always going to bring out a double star, a variable star, because that's the thing I love to talk about. Um, whatever is happening in the deep sky, and whatever is happening in the world of spaceflight. And something to wrap things up, just in case it's cloudy. Not that that could ever happen. So, starting off with the big picture, heading out tonight at 7:30. Right now, if you went outside and saw through the clouds, this is how the sky would be looking towards the west. Our favorite summer constellations are finally getting over the edge of the horizon, but we do have a pretty good selection of planets, starting with Venus, Saturn, Neptune, Uranus, and Jupiter all in a row. Um, if this was a wider screen, you could actually carry it on further to Mars. So it's a pretty impressive selection of planets up tonight. And of course, all your favorite winter constellations are up there, Orion and Taurus and Monoceros and all those spectacular bright winter constellations. When we come back to the last observing before our next meeting, 5:30 in the morning on February 5th, we will start to see our summer constellations, spring constellations appearing in the eastern sky. Um, the price of getting all those great planets in the evening sky means the morning sky is pretty dry as far as planets are concerned. But we do have all our great spring constellations and a promise of summer constellations in the near future. So key dates coming up. January 29th is going to be the new moon. The moon will be occulting Saturn for people who aren't in the Toronto area. We're talking about people in the southern hemisphere mostly. Quadranted meteor showers are going to peak on January 3rd. Mars is going to have its closest approach, the closest physical approach on January 12th. And
Sorry for the technical issues, ladies and gentlemen. We're just going to quickly go over to fun facts, and we will be back with you shortly. And now we're going to start restart Andy's presentation. So bring her over.
Okay. All right. Okay. Sorry about that. Technology curses us all once again. Anyway, key dates: the new moon on the 29th, moon occulting Saturn on the 4th, quadranted meteors on January 3rd, Mars approaching on January 12th, and the moon occulting Mars on January 14th. So moving on to the sun. Nights are getting shorter. So astronomical twilight is ending at 6:15 tonight, starts again at 5:52 in the morning. This is Eastern Standard Time. Uh, and when we get to February 5th, uh, twilight ends at 6:55. So we get less night and then starts at 5:35 in the morning. As we are probably aware, the sun is in a particularly active phase right now. So if you have a solar telescope, step out there, watch for sunsets and prominences. I was looking at spaceweather.com earlier, and it tells me that sunspot 3936 poses a threat for X-class solar flares. And for people who don't know what X-class solar flares are, like I didn't this morning, uh, those are the big ones. Those are the ones that give us big auroral displays, cause radio disruption, and all the things that you can get out of a good solar flare. Meteors. We've got the quadranted meteor shower peaking on January 3rd, uh, potentially 120 meteors an hour, and a favorable phase of the moon. So if you can stand the cold weather and it's actually clear where you are, this is going to be one of the better meteor showers this year. Minor showers going on, less than 10 meteors an hour. The only one going on right now are the Coma Berenices. They peaked on December 15th, but it's a long duration shower, so we're still going to see some meteor activity from that shower. And a few meteor dribbles, less than 2 meteors an hour. The Omicron Leonids, the Xi Corona Borealids, and the Gamma Ursa Minorids. None of those are actually interesting enough to get out of bed and go and look for. But if you are out observing and you do see a meteor, and it's not one of the ones you're expecting from the major meteor shower, trace back its direction of origin and see if you can pin it down as a member of one of these very, very minor meteor showers. The aurora, well, I didn't see last night's outburst. It was cloudy here. If anybody did see it, I would be interested to hear about it. Post a comment or contact me later with whatever means you have. Um, I don't know what's coming tonight or in the immediate future. The sun does what it wants to do, but the sun is in a particularly active time right now, so hopefully we will get another interesting auroral show soon. Spaceweather.com is the place to go for the latest updates. That's where I was looking this morning and finding about active sunspots. So in the near in the over the next month, keep an eye on it. I'm expecting the odds are high we're going to get another good display. So the moon, the photographer's bane. We have the new moon on January 29th, first quarter January 6th and February 5th, full moon on January 13th, and the last quarter on the 21st. The moon will be at its farthest, or apogee, on January 20th, and closest at perigee on January 8th and February 2nd. An observing project I always like to suggest to beginners is take a picture at apogee and perigee with the same equipment and compare them to see how the size of the moon changes as evidence of its elliptical orbit around the Earth. Lunar X is it's a fun observing project. It's a point of time in the month where the angle of the sunlight coming across the moon intersects the rims of two craters right beside each other and lights them up and makes it look like an X on the surface of the moon. Does it have any scientific significance? None. None whatsoever. It just looks neat. And a couple nights, this time it's happening at 12:10 p.m. This is Eastern Standard Time. During the day, I've never been able to spot the lunar X during the daytime, but I don't see any reason why you wouldn't be able to with a reasonably uh, good telescope. That's an experiment for somebody to try if they're looking for a science fair project or something like that. The straight wall is another feature on the surface of the moon. It just it's a straight feature which, when illuminated by at a certain angle, makes a nice dark line right across the moon. It's a neat thing to look at. Um, Another observing project if you're out observing on the 8th and the moon's there. Yeah, put it in. So, Saturn is going to be occulted by the moon on January 4th. If you live in South America or most of Europe, it should be visible. For those of us here in North America, we are out of luck. We are not going to see it. What we will get is a close pass of Saturn going by the moon, and that makes neat photographs. So if you've got a clear night on the 4th, take out your telescope and your camera and see if you can get a neat photo for your collection. Now, here we have an occultation of Mars around 4 o'clock Universal Time on January 14th. Um, that one actually has some scientific value if you have the equipment to measure its appearance and disappearance precisely. The International Occultation Timing Association uh, collects that kind of data and uses it to make precise measurements of the position of the moon. It's a it's a small way that you and I can get involved in real science. So the rocky planets, Mercury in morning twilight, it's actually a good time to see it at the beginning of the month, but as the month progresses, it will go further and further away. Venus is the big one, very bright and prominent in the west after sunset. I'm already hearing people talk about it, getting reports of it as a UFO. It's not a UFO. If you hear anybody talking about it, tell them it's Venus. Um, I've actually heard some pretty outrageous reports in the past of what people imagine they see when they see Venus and don't understand what they're seeing. Their imagination can fill in a lot of details that aren't there. So when you hear people talking about UFOs, and I know this is a big hot subject because of the whole drone thing going on now in the States, um, remember that Venus is there, and don't be afraid to spread a little science around. Uh, Mars is actually at one of its best apparitions all year right now. Its closest approach on the 12th and in opposition on January 14th. Now, the fact that those two dates are not the same is evidence that Mars and Earth are both on elliptical orbits. So the opposition and closest approach don't quite match up. But we're still looking at the best opportunity of the year to have a look at it. It'll be minus 1.4 magnitude, very bright, 15 arc seconds in diameter, which means it's a good opportunity to see a lot of surface features that we haven't been seeing for a long time. It's going to, you'll definitely see ice caps, some of the major dark features, and it's going to be very high in the sky, so we're not looking at a lot of problem with the atmosphere as well. A challenge I always like to issue to people is: have you seen Mars's moons, and can you spot them? It takes a bit of preparation. Um, One of my favorite techniques is to set up your telescope where Mars is going to cross a telephone pole or something like that, so you can see what's beside Mars when it's been blocked by a solid object. I have not yet had any success in finding the moons, but we keep trying. Gas giants, Jupiter rising in the afternoon and sets around 5:30 in the morning, so it's going to be up there all night. Extremely bright, minus 2.7 magnitude, and very close to opposition. So once again, you're at the best views we're going to get. It's just about as close as it's going to be. It's bright. It's big. This is a really good time to look for Jupiter. I'm hearing reports from friends that the red spot is getting darker. The last time I saw it, it was the pale pink salmon spot, and now I'm hoping it's a bit more visible. There was a talk a while ago that it was dissipating and going away, so it looks like that isn't happening. Saturn is not in as good position. It's sinking in the west. By 10 p.m., it'll be gone. The rings are very close to edge on, which is a disappointment for anybody looking at Saturn because everybody loves to see the rings. And this is actually the last we're going to see of the north side of the rings for some decades. By the time it comes around on the other side of the sun, we'll have gone through the point of absolute even on for the rings, and then we'll be looking at the south side as Saturn tilts that way. Um, it's going to be a little while before we see any ring phenomena worth taking a telescope out for, but with the rings very close to edge on, this is a really good time to go searching for Saturn's moons. Um, there are 7 listed in the Observer's Handbook of brighter than 13th magnitude. Titan is extremely obvious, but the others should be manageable with, say, an 8-inch or better telescope. The ice giants, also in the night sky. Uranus is visible almost all night in Taurus, under 6 magnitude, so easy to see with binoculars. It's only 4 arc seconds across. I very much doubt you or I are going to see any features because the features there are very subtle, and Uranus is not big, so you're not going to see much. But uh, if you have a largest telescope, there are probably 5 moons in reach. So that's probably the most interesting observing project you're going to get with Uranus. Neptune rises in the daytime and sets around 11:30 in Pisces. It's eighth magnitude, about half the size of Uranus. The moon Triton is visible. I don't think any of the other ones are interesting or achievable with telescopes you and I are likely to have. Um, the last time I was doing this talk, which was back in October, I asked people to compare the colors, which one's blue, which one's green. Can you actually tell the difference? And I'd be curious to hear if anybody went and did that observation and what they found. So the dwarf planets, yeah, sorry, dwarf planet fans, it's lousy. Um, Pluto and Ceres are both too close to the sun to be observable in any meaningful way. I guess Ceres you might go at its seventh magnitude, but it's going to be in terrible condition, a terrible position to see. So I think we'll just set those ones aside and wait for them to come back in the spring. So asteroids, I fired up my planetarium program and said, show me all the asteroids brighter than 9.5 magnitude. We have a half a dozen there. Vesta is a particularly bright one. I like asteroids as a observing project because you can go back and look at the same asteroid 3 or 4 nights later and see motion against the night sky, motion compared to the background stars. So make a careful sketch of where your asteroid is sitting compared to local stars. Come back a few nights later, make another sketch, and you'll be able to track it over as long as you like. Exact coordinates for these asteroids, I'm not going to type them in here because you can look them up in your observer's handbook or most planetarium software or on the internet. And, save trying to scramble to write them down while I'm talking here. We don't have any really great comets going on right now. C2024 G3 Atlas in Scorpius is bright but extremely close to the morning sun. You might be able to see it, but I don't expect to be able to see much of it. Other than that, um, C2023A3 Tsushinshan Atlas. We were all out in the fall looking for what we hoped was the most spectacular comet of the year, and it was pretty good. Visible from downtown Toronto with the naked eye, if you're absolutely certain where you're looking, maybe. Anyway, it's down around 9.6 magnitude in Aquila. If you missed it last time I was talking, well, it's still out there. Go and look for it. 29P Schwarzmann-Walkman in Leo, 10.9 magnitude, and 2023 Q1 Pan-STARRS in Campbell-Lepardis. That's about all we're going to get brighter than 12th magnitude unless something unexpected happens. And it is the nature of comets that something unexpected happens. So, yeah, keep an eye out. Something may happen. So, a double star, thinking about you, Blake. Beta Orionis, aka Rigel. A 0.3 magnitude and 6.8 magnitude pair, quite far apart, 9.3 arc seconds. The catch is, and this is the same deal we were talking about with Mars, you get one extremely bright object and one much dimmer object. The bright one tends to wash it away. So the solution, set up so the primary star, the bright one, is hidden by a wall or a post, and search for the secondary while it's still hidden. There is a third spectroscopic component which makes the primary into an eclipsing variable. It's not a big effect because it's a small object and Rigel is a big and extremely bright star. But if you're interested in a variable star project, this one probably takes a photometer because the difference is going to be very subtle, but it's an interesting observing project nonetheless. Now, you got to have a variable star, T Orionis. It's a UX Orionis type star, and what that means is the brightness is changing not because intrinsic brightness within the star, but in this case, it's being surrounded by a circumstellar disk of dust and rock and debris. And as clumps of material pass between us and the sun, the brightness dips. So the periodicity is irregular. It changes with rapidly and in unexpected ways, and that makes it a good candidate for visual observation. Um, as you know, there are an awful lot of automated sky surveys happening now, where the sky gets photographed every 2 or 3 days. The projects where amateur astronomers still have the most value are the variable stars that change brightness the most rapidly. Things like cataclysmic variables or things like these UX Orionis type stars. If you're interested in contributing to science, like I always encourage people to do, the American Association of Variable Star Observers, aavso.org, will be interested in collecting your observations. The website is full of instructions and helpful advice. So if you're interested in getting started in this fascinating bit of science, please feel free to contact me offline, and I will be happy to make all kinds of useful suggestions. Which now the other variable star on my mind here, T Corona Borealis. Um, Anybody who remembered my talk back in the spring can probably remember my confident prediction that this summer we were going to see an outburst, the first since 1946, when T Corona Borealis, the blaze star, became the brightest star in the constellation of Corona Borealis, and it would be the spectacular variable star event of the decade. Of course, nothing happened. It's still We're still waiting. It hasn't happened yet. It's way overdue. Um, so a lot of scientists are scratching their heads, wondering what's going on. Are our theories wrong? Keep an eye on this. If you're the first person to spot it going into outburst, your name will live forever among the annals of variable star observers. So here's a map of it. Here we have our traditional Corona Borealis circle, and down to the bottom left, it doesn't show on the screen here because it's such a tiny and uninteresting star most of the time. But that's where it is. And if you go out on a clear night and you suddenly see the brightest star in the constellation in that position, that is the star. So I like to suggest something for the deep sky, get people out having a look. M37, open cluster in Auriga. It's an excellent object especially if you're doing your Messier catalog. Um, M36 and M38 are near neighbors. There's the number. You can get 2.7% of your Messier list in 15 minutes by just taking your binoculars and looking up at Auriga. Uh, it's a really nice looking constellation, or a nice looking cluster. Um, Here we have an image of it. Notice a lot of color variation between the blue and the red stars in it. Um, if you have a decent sized telescope, you should be able to see color variation, see that the red giants, of which there are many, are noticeably red. This one is an interesting cluster in that it is one of three that contains a planetary nebula. Um, yeah, it's not a particularly famous planetary nebula. That is not a number I have memorized. And I don't think I've ever heard of anybody visually spotting it, but it apparently can be photographed with a very long exposure. So it's a project that you astrophotographers might want to have a look at. So for something more challenging, for those of you who have completed your Messier list and looking for something a bit more fun, M1, it is a Messier object. I found it was the toughest of all of the ones I was looking for. Um, it's a fuzzy blob, and I've looked at it through a telescope and a big telescope that I borrowed, and it was never anything more than a fuzzy blob. Um, there was no way I was going to see a 17th magnitude neutron star in the center with any telescope that I could get a hold of. I suppose if we fired up the telescope at the DDO one night, we might be able to, but I wouldn't count on it. Where it really shines is in the world of imaging. Um, the pulsar at the center is a 17th magnitude object, but it flickers on and off at 30 times a second. There's a famous observing project where someone set up a rotating, basically like a propeller, which blocked it at a rate of 30 times a second. And they actually imaged two images, one where it was always blocked and the pulsar disappeared, and the other where it was always there. So obviously, that's not going to be something for us in our amateur equipment, but it's an interesting idea. You can grasp the expansion of the Crab Nebula by looking at images that have been taken over the years, and by taking images with different filters, different wavelengths, you can have a look at its chemical makeup, see what's hydrogen, what's oxygen, all those other materials that you get with the fallout of a supernova explosion. Now, the picture I've got here, this was actually taken by our friend Strada using a C star 50. And I've asked her if I could use this image because what I wanted to show people was it takes it, you don't need a giant telescope to do some cool imaging. This was basically a 2-inch automated telescope. Um, I think she was saying online that this was about an hour's worth of 10-second exposures, all stacked, expertly processed by her to make a very nice image. Um, I would just like to point out that okay, well, hey, this is way better than any photographs I ever took, but I could see at least the data gathering part would be within the grasp of any of us. So coming up in spaceflight, not a lot of exciting stuff happening. The New Glenn test flight with an attempted booster landing is coming up on January 6th. Blue Ghost Mission 1, a commercial lunar lander, is planned for sometime in mid-January. I haven't heard the specific date. It's been postponed a couple of times, so we'll see what happens. Decision to be made about recovery of Mars samples. NASA is going to be talking about that in the new year. We'll see what they decide there. The ISS will be passing overhead in the mornings until January 4th, and evening passes from January 11th until February 1st. Heavensabove.com has the exact time for your own specific location. I still all these years later, I still love going out and seeing the space station flying over. It's a little bit even more interesting now because the two space-wrecked astronauts from the Starliner mission are still up there waiting for rescue. It's almost like something out of a science fiction movie, isn't it? So is it cloudy out? It looks cloudy out to me. Um, is it clear and cold and you just want to sit on the couch and drink hot chocolate? Then Galaxy Zoo is a place where you can go and do some real astronomical science without leaving the comfort of your nice warm house. There are literally dozens of projects there, and some that I've just arbitrarily picked this month because they look fun. Planet Hunters Transit Survey, where you're going to be checking the photometry from various space missions, looking to see any stars which have a characteristic dip in their brightness, telling the scientists that there's a planet there. Eclipsing Binary Patrol, looking for eclipsing binary stars. Burst Chaser, helping to track down information about gamma ray bursts. And Cool Neighbors, looking for brown dwarfs that have been detected but or measured, but not actually uh, confirmed by human scientists. This is a cool project for those of us who want to get in there and you know, brown dwarfs. It's one of the cutting edge subjects of science. Where are they? We can go out there and have a look ourselves. So that's all I've got. If you have questions, you can email me at andy.beaton@gmail.com. I'm on Blue Sky and the RASC Toronto Centre Forum, and I'm happy to answer any questions or give advice for getting into the world of observing variable stars. So thanks very much.
All right. Thank you very much, Andy, for the sky this month. Just to answer your questions, comparing Uranus and Neptune, to my mind, Uranus is the paler of the two. Viewed through a telescope, Neptune is darker,
Good.
shade of blue. And I've never seen the moons of Mars, but I have seen through an 8-inch the cloud bank over Mount Olympus Mons.
Oh, excellent. That would be a good observing project too.
All right.
Martian weather should be on everybody's list.
Uh, just do we have any questions for Andy?
There aren't any questions, but there are a few comments. Eric Briggs wrote that he remembers stepping out of the Astronomy and Space Exploration Symposium at the University of Toronto on January 19th, 2008, the last time the full moon and Mars at the opposition were together overhead in the evening sky.
It would make a good pair for a photograph.
Yes. Uh, Eric Briggs also commented, taking care of T. Corona Borealis business.
It never crossed my mind that taking care of business and T. Corona Borealis had the same initials, but now I will never get that out of my head. Thanks very much, Eric.
John Wonderlich said it's difficult to make predictions, especially about the future.
Predictions about the past are a lot easier, yes.
Yes, and
but I recognize the Plan 9 reference, so well done.
And Stephen R12 had said, this sea star has been a great tool for me to discover more about space.
I have not heard anybody say bad things about their sea stars yet. The only thing I would miss about it, it is not a visual telescope.
And I think that's pretty much it. Lewis R commented that he likes it too, especially when it's not cloudy.
Well, I can't promise not clouds.
True. But that's about it.
Okay, well, thanks very much. I apologize for the technical issues. I'm going to be taking a hammer to my telescope or to my computer as soon as I'm done here.
Thanks again, Andy. All right. So, one quick announcement before we move on to my presentation. We're putting together a tour for Toronto Centre members of the Alan I. Carswell Observatory at York University to take place before the next Recreational Astronomy night in February. So, we'll be posting something up in the forum in the next couple of days or so about details and so forth. So, let's get on then to my presentation. Oops. All right. Are we not sharing? Oh, it is on mine. Okay, hang on one split second here. Technology. Gotta love it. All right, let's try this again. Okay. And how are we now? Hmm. Okay, let me. Okay, let's try something else then. All right. Apologies for the minor technical glitches. Technology. All right, ladies and gentlemen. So, 2024 was a fairly good year for auroras, which is putting it mildly. And there have been a lot of questions online about what's going on and why does the sky every few months turn purple and green. So I figured that this would be a good time to talk about what's been going on. So I'm going to cover what's happened for auroras in 2024 in detail. I'm going to be talking about what is the cause of all these auroras, why was 2024 so spectacular, and a little predictions about the future, what the future might be bringing for us. So, 2024 was the most spectacular year for auroras this century. We saw the largest aurora in 2 decades. Um, we've had two major, one in May and one in October. And I'm just going to start off by going through some of the images that I took myself of our auroras here. So, just to set the stage for you, for those of you who don't quite remember, um, May 10th, 2024. Um, by coincidence, I happened to be at my parents' place, which is near Coburg, Ontario, and for that weekend. And so the sky is partly cloudy, as you can see here, but it's just the occasional puffy cloud and not completely socked in. And we've got a crescent moon setting in the west. And as darkness falls, this is about 5 minutes before 10 o'clock then that evening. We've got Leo right here in the center of the screen. And you can see there's a bit of a haze, sort of a purplish. Similarly, we've got being springtime, the Big Dipper is at the zenith and it's upside down, and it's also got a purplish haze. And I was thinking to myself, okay, this is looking fairly interesting. And then about 5 minutes later, this starts happening. This big, beautiful streamer starts crossing the sky. But notice something. Here's Leo again, and at the top. And Leo is, of course, in more in the south sky. So we're looking. This is looking southwards at an aurora in southern Ontario. And then about 5 minutes later, it passes directly overhead, and everything goes nuts. The sky is a giant collection of greens and purples, uh, big giant sheets of light all across the sky. To put it into context, let me show you something. Here's an overexposed crescent moon just above the house. Leo, again, is this pattern of stars up here, now buried in the bright purples and reds. We've got colored sheets of light all over the northern sky. And side note, the reason why this hydropole is so prominent in the middle is because it's blocking the street light from further down the road. So I'm standing in its shadow. So that's kind of why it's there, as opposed to, why I had to couldn't move a little ways to get it out of the way. Sometimes you have to, uh, sometimes when you're doing some photography, you're limited by what you've got in the area. More sheets of light now in the western sky. Just for reference, we've got Pollux and Castor and Gemini in the upper right, and then dead center in the field of view is Procyon. Again, lights everywhere across the sky for at least half hour, 45 minutes. And looking straight up, we're looking straight up into the streamer itself as it passes around the Earth. And so there's actual real structure visible in this aurora as we're looking at it. Again, looking towards the northwest, Capella over on the right, the twins in the dead center, moon right above the house. The Big Dipper at the top of the screen there, and more. It's almost like being in a rainstorm. The way that these apparent rays are shimmering all through the sky. And again, you look straight up, and there's this detailed structure, this moving, writhing, uh, snake-like pattern in the plasma. So as the time ticks on, the aurora moves off from directly overhead and starts moving up north, farther to the north in the sky. It's a great mixture of purple and green, but there's the occasional tint of blue as well. This is probably my favorite photo I happen to be able to snag. So we're looking southwest, Corvus, dead center. The bright star up here in the branches of the tree is Spica. And then it's all framed by the aurora and the clouds at the bottom and the trees lit by a couple of street lights to the south. And then, unfortunately, though, within about an hour, the clouds start moving in and things get a little dimmer. And so I decided to take a break here. For reference, down here in the lower right is Lyra and Vega. And then this here, trapezoid, is the head of Draco. So the clouds are moving in. So I take a break. I come back out 2 hours later, and the colors have definitely dimmed. We've gone from brilliant neon green down to green so faint it might as well be gray. For reference, here on the right is Cygnus rising in the northeast, and Deneb is here. Somewhere here in this mess is the North American Nebula. And again, we've got sheets of green light in the north. Moving on to last October, just about 3 months ago. Now, this aurora is not as intense as in May. Again, I happened to be in Coburg for that weekend because, as I recall, it's Thanksgiving. So anyway, starts out with very dense, very dark purple in the northeast, but not really as much overhead as we had previously. Here's Cassiopeia, dead center. The square of Pegasus is right now a lovely shade of magenta. Now it's October, so the sky, the Big Dipper has rotated 180 degrees. So down here in the lower right, we've got the tail of the Dipper arcing to Arcturus, and then constellation of Boats over here. Looking to the northeast, the color has dimmed a bit, but it allows the stars to pop out. And I don't know if you can, we got Cassiopeia here on the left and Perseus rising up on the trees. And I don't know if it comes out on the screen, but absolutely dead smack center, you can just make out the Andromeda Galaxy. Big Dipper over the house, Polaris and the Little Dipper up at the top. And again, sheets of green and red, purple up in the north, with more blue this time. And strangely enough, an occasion, the red and the green overlaps one another, and you get sort of a bronze or coppery color. This was unusual. I hadn't never experienced this myself. So if you look carefully up in the north, there is occasional patches of bronze-colored aurora. And at one point around midnight, as you can see here, to be honest, it's not looking very regal aurora. It's actually looking a little more like 1970s pollution. So what exactly has been going on here? Well, the basic thing to create an aurora, you need three things. You need a star, and you need a planet with a magnetic field and an atmosphere. So our sun is constantly emitting charged particles. This is called the solar wind. Now, the strength of the solar wind varies, just like the wind does here on Earth. There's a constant flow, but events on the sun's surface, like solar flares and coronal mass ejections, basically cause explosions on the sun that blast out huge numbers of these charged particles. When these charged particles reach the Earth, and they're moving fast because the 150 million kilometers distance between the sun and the Earth um, is covered in days. In fact, in one case, the record time for this stuff to hit us is 17 hours. So when these particles reach Earth, they interact with our magnetic field. And a lot of them get deflected away, but some of them get funneled by the Earth's magnetic field down towards the magnetic poles. And during large events with a large number of particles, they get forced into the upper atmosphere. And the large number of particles react with a large number of gases in our upper atmosphere. So this is just a quick diagram. As I've said, the sun and solar wind and the solar eruptions, the particles come and hit. Some of them get deflected away from Earth by its magnetic field, and some of them get funneled down into the poles. Some particles also end up getting slowed by the magnetic field and then get dragged back. So the particles interact with gases up high in the atmosphere, and they ionize those gases, and that's what causes them to glow. The green color that's most commonly seen is ionized oxygen at an altitude of around 100 to 300 kilometers. If you're a deep sky observer, you know this color very, very well. It's the same ionized oxygen we get from certain deep sky objects, like planetary nebulae. So, in fact, yeah, it's the same oxygen green. The reddish purple color you get is occurs 3 to 400 kilometers higher up in the sky. The interactions are usually not as active or as bright, and so that's why it takes a really big solar event to create enough interactions to create all this red light. Which is why whenever you see an aurora, most times when you see an aurora at latitudes like where we are here in Toronto, it's because it's so energetic that there's so much red light. So the largest solar eruption observed was the Carrington event in 1859. This aurora that was created by it was bright enough that you could read by it at Toronto latitudes and was visible as far south as the Caribbean. The Carrington event was has been estimated to be 2 to 4.5 times bigger than the May 2024 one. So, why was 2024 so spectacular of a year? Well, the sun has an activity cycle. And this activity cycle is approximately 11 years, and no surprise, it's called the solar cycle. Um, Approximately 11 years, it has been as short as 9 and as long as 13 in history. We are currently in cycle 25, which officially began in December of 2019. So we're 5 years into what we think is an 11-year cycle. So what this means is that it is likely that the cycle will peak in the next few months. It is possible that it has peaked just recently. We won't know exactly when this happens until a few months after it has peaked, and we can confirm the numbers are actually dropping and it's not just a minor statistical or just a minor movement. What this means, the more active the sun is, the more and larger sunspots there are. This is, in fact, how we started counting solar cycles. Sunspots have been observed through telescopes since the mid 1700s. And so cycle one began in the mid 1700s. That's how we got up to cycle 25. It also means, though, that there are more solar flares and more coronal mass ejections, which gives us more chances for auroras and more chances for bigger auroras. Now, second reason why 2024 has been so spectacular. Cycle 25 is the biggest cycle that has happened in several years. We are already 67% higher than the maximum of height of cycle 24 and still climbing apparently. Some estimates are that cycle 25 may be the largest solar cycle in 4 decades. We'll find out in the next few weeks or months. And there's one other reason why 2024 is so spectacular, and that's more technological. Social media has been getting the word out because the last time we had auroras of the magnitude that we did back in May was in 2003. So before social media really was the thing. And technology has also advanced. Every single photo that I've shown you was taken with this smartphone. My Samsung has a built-in low light automatic 4-second long exposure setting. Literally every single one of those photos was taken by holding up the camera and trying to move as little as possible for 4 seconds. By comparison, for those of you who are a little younger, in 2003, film cameras were still very much a thing. I remember being in university, and one project that we were working on, the first question we asked was, does anyone know anyone with a digital camera we could borrow? So, with all that in mind, what might the future bring for us? Well, 2025 may very well see a repeat of 2024. As I said, cycle 25 appears to be still climbing. Exactly when it peaks and how it'll depend on how quickly or when cycle 25 actually peaks, how high it peaks, and how quickly it declines. Cycles are not necessarily a smooth bell curve up and down. It could very easily be that the cycle 25 reaches a height, drops dramatically, and then peters out over several more years. It could also be possible that cycle 25 just continues upwards like this and then finally comes to an end in 2 years and then has a high peak in 2 years and drops off dramatically from that. We don't know. Each cycle is slightly different. So keep an eye on the news and websites like spaceweather.com. And here's hoping that we've still got a couple more good shows coming up this year. So I want to thank you all very much for attending my talk. And I'd like to, if there are any questions.
Yes. There is one question, and it's from Guy Yanez from Chile, who's from Chile, an area near Santiago, Chile, in the mountains, I understand. He asks, this is the guy here from Chile. Ionized gases in the atmosphere are mostly green, but there are also these red ionized gases even higher up in the atmosphere. Why are these all of a sudden so bright?
So the red light that's produced, it's oxygen as well. It's just that both colors are produced in an aurora. But the thing is that the red at the high altitude, those really high altitudes, the oxygen is so dispersed. It's such low pressure that the amount of red light that gets generated is very low compared to the green light. So the green is much more easily seen. But when you have a big enough event, the number of charged particles that reach the upper atmosphere is much higher, and the amount of light that gets produced is much higher, so that the red really starts to show through.
No, uh, those are all the questions. Yes.
Okay, wonderful. All right. Well, thank you very much, everybody, and thank you very much for joining us this evening. And now it is my pleasure to pass things on to our newly elected president, Scott Masterton, who will be giving the announcements for the evening. Scott, whenever you're ready.
Thank you. Thank you, Tom. So, greetings, everyone. I'm glad you could join us tonight. And this is my first run through on the announcements as president, and try and do as good a job as Tom has done. So, the announcement for today. First, I want to welcome you folks for being with us to listen to our presentation. I should just explain what type of meetings we have. We have two meetings, a RAN, or Recreational Astronomy Night, where members present information about their investigations, just as Tom has done. And then the other meeting that we have is the Speakers Night, and that is done online because we draw on speakers from all over the world, and they can be very interesting as well. It gives us a much broader base. Oh, and I should remind you that you can use the utilities associated with YouTube to say hi. Use the chat function, enter questions for presenters, just as our chap from Chile has done. And if you're a new member, you could introduce yourself, and you should give that a try. Speakers Night. Speakers Night meeting will be on January the 15th, 7:30 online. And our speaker has yet to be identified, but we will pass that information on to you. You can, of course, connect to YouTube with at the URL seen below. Recreational Astronomy Night for Wednesday, February the 5th at 7:30, just as we've had today. And this meeting will be in person, online, a hybrid type of meeting. And the speakers will present as follows: Claudio Oriani, The Sky This Month, and two more presentation slots that are yet to be determined. And again, access is by the URL below. Mars Madness, the red planet at opposition. And as was explained, opposition occurs when the Earth is between the sun and the planet in opposition. And because of that, when the sun sets, the planet rises, and it will be as close as it's going to get for some time, 26 months, the orbit of Mars, and it'll be large and bright. The registration fees are as indicated, and you can register online at rasto.ca. Astronomy Speakers Night, and this occurs at the David Dunlop Observatory on January 11th between 7 and 9. Katerina Ostertag, her talk is about blazars, cosmic cannons of supermassive black holes. Fortunately, we're not in the target area. Registration fee is as indicated, and again, go to Rasto to register online. DDO Astronomy special occurrence Sunday, January 26th at 12:30 to 1 p.m. online again. virtual Sunday sun gazing. We used to do this in person, but we're now doing it online. The registration fee is as indicated, and again, links can be found at rasto.ca. And the Carr Astronomical Observatory, our observatory up in Collingwood, the CAO. We now have year-round access because we're plowing the roads, and I'm told that the roads are clear right now. Operations are largely back to pre-pandemic conditions, and masking is encouraged, but it can be modified according to those in attendance. Check online the CAO bookings page for details at the URL indicated. And of course, we can always use volunteers. We encourage you to give us a hand. If you're an RASC member, or if you're not, you can become one. And if you're interested in helping us, we'd certainly appreciate that. Contact the volunteer coordination team at volunteer@rasto.ca. And of course, if you want to become a member, if this talk was interesting to you and you'd like to become more involved, you can renew or sign up online at the URL indicated, and gift memberships are available through the national office. And thank you for joining us tonight. Have a great time.